Okay, thank you everybody for joining the webinar. So today, I will share with you some information of of hybrid inverter. The power rate is from 7.6 kilowatts to 12 kilowatt. And after a brief introduction of our inverter, I will introduce the working modes. Because we have promoted our product in the US market for a while, and some people want us to improve our working mode settings. So actually, this year we released another website version setting page to make it easier to set the working modes. So today I will share more about it. So these are the main contents of today. First, I will introduce the hybrid series, the features, and then the working modes introduction. What is all working modes work like? And last, I will show how to set these working modes. So let's go to the part 1, hybrid series introduction. Here we list all the models we have for hybrid inverter like LXP. Like originally is from 8, 10, and 12. According to the breaker size in America, the house used and also the law of 120% like overcurrent protection. So we have some other models like 7.6 kilowatt, 9.6 kilowatt, and 11.4 kilowatt. So there are more options for the power rate for the customers according to the breakers in their house. Besides the residential solution like these inverters, you can, since we already get the certificate for the American market, you can not only install this in the residential, but also in a small business, because the biggest one is 12 kilowatt, and we support parallel function. So customer can also use it as used in the small commercial part. Here is the 12 kilowatt, some features of the 12 kilowatt hybrid. So first is a low voltage one, is 48 volts battery connection. As you know that first, the advantages are first, there are the cost of low voltage battery is lower, and also there are more options for customer to choose the battery. Then with this inverter, we have passed all the certificates which require in the US market, like the UL, the SunSpec, and the CEC list. Then with this one, we have 200 amps pass-through current.
Thank you.
As you know that there are some houses in the America with 200 amps requirement. So
Oops. I did it.
sorry, let me unmute him. Let's unmute. Okay, let's continue. We have 200 amps pass-through ability, which makes the installation easier and lower cost. Next one, we have the load and the battery breakers integrated. So as you know that there must be a breaker between the battery and the inverter. This also saves the cost and installation time with integrated breaker. As also the regulation requirements, the RSD and the FCI is a must in the solar system, and all of these are integrated in our system too, in the inverter. Then with also in the cable box, there are some there is generator port. With the generator port, we can have some functions like we can control the generator, connect the generator and control the generator. Then we may also use this port as AC coupling function and then smart load. So actually for the generator port, with the generator port, we can do many things, which I will have introduction for this part with the next webinar. In this webinar, we will focus on the working modes. And then last one is we have true color touch screen. So these are all the hardware features which we like equipped in our cable box. So it is a very convenient install. It will be a very fast installation with all the breakers you need in the cable box. Also like the FCI RSD are integrated. For that is 12 kilowatt. We also have like 7.6, 8, 9.6, and 10 kilowatt for American market too. The features are very similar to the 12 kilowatt. The power is lower, which make the more options for the houses. And it is also low voltage battery, pass the certificate with breakers. And with for this model, we have like generator breakers, which 12 kilowatt doesn't have. And then RSD, FCI, generator port, and the touch screen. So now with this, with the 10 kilowatt, we have like here load breaker, battery breaker, generator breaker, and the AC input breaker now. But in future, we will remove the AC input breaker because you already have the breaker in your box. And then increase the pass-through current for this AC input. I will introduce a little bit later here. So there are some parameters for 12 kilowatt and 10 kilowatt. Actually, there are many models, so I just say 12 kilowatt in short. So you know it's this series. There are some parameter listed for the difference between 12K and 10K. So for the 12K, also some key parameters for you when you choose the inverter. So for the 12 kilowatt, we have 3 MPPTs and 4 streams input. The maximum PV input can be 18 kilowatt. For the 10 kilowatt is a similar number. So it's like also the 1.5 P nominal for the PV input. So for 10 kilowatt, the maximum PV solar input can be 15 kilowatt. And the battery side for the 12 kilowatt, the battery current, maximum charge and discharge current can be 250 amps. With the 10 kilowatt, the maximum charge and discharge current can be 210 amps. So you can see that actually this parameter is very advanced in this market. So for some other brands, they also like promote 12, 11 or 11.4 or 12, but they may only have like 200 amps current. So it's very advanced parameter in this area. For the AC part, the maximum AC output is 12 kilowatt for 12 model and 10 kilowatt for 10 kilowatt model. Another feature is 200 amps by pass-through function, pass-through ability. So I mentioned that before. For the home backup, it saves the cost for some box if we have the 200 amps pass-through. And for the AC input for the 10 kilowatt, it is a little bit different. Now we have a breaker there, which is 63 amps pass-through breaker, and so the ability is like 63 amps. But in short future, we will remove the AC input breaker and make the terminals bigger to pass bigger current, because in some situation you may want to charge the battery and take load same time. So in this case, it gives you more power from the AC side. The next one is the generator. For the 12 kilowatt, both inverters have separate generator input, and for the 12 kilowatt, the maximum input is 90 amps input, so you can take load and charge battery. For the 10 kilowatt, the maximum is 63 amps now, but in short future, we will change to 80 amps so you also have more ability to handle the generator power to charge battery and take load. These are the key parameters for the 12 kilowatt and 10 kilowatt. So next we can see very short, briefly, we can see some features. First is parallel. So this also the parallel ability makes you to use this inverter in some small commercial applications. Now we support 10 units parallel, and it can be like split phase parallel and 3-phase parallel. Also that so you can see in this picture, each inverter is connected to their own battery. This also is like a big advantage when installation. You do not, we support each inverter connects their own battery group. So you don't have to connect all the batteries together as a big battery bank, because it will cost the time and the money to make a big battery bank. So this is the parallel function. And also we just mentioned in the previous page, we have a separate generator port here. For this port, we can support like smart load, so which you can turn off some loads on important loads when the SOC is low to save the energy for more, to let the system work for longer time. And also AC coupling function, which may be very useful after the California law for the market. So you cannot sell the power to the grid for get a lot of pay. So it's better to use as you make your originally on-grid system to a storage system. With our inverter, you can also do that with the AC coupling function. So the whole system will work with our hybrid inverter, and the on-grid inverter will work as a whole system to handle the power. And also the other advantage is with the AC coupling function, when there is utility is interrupted, the whole system can keep working. So you won't waste the on-grid system's energy when there is load shedding. So the next one is the generator. We also have many functions with the generator, like we will have the gen exercise function, which you can turn on the generator regularly to make sure your generator is good. And also we can remote turn on and turn off the generator according to your settings. And also that way, for some generator, you can set like warm up or warm up for the generator. So I will introduce this part in the next webinar in detail. This is another feature. So actually, if you have used our inverter, you may know that we have our own monitor system, which is developed by our own team. And also that there are many advantages for our monitor system, like we can remote control and monitoring. The other one is we show in this picture is the battery part. So in previous monitor system, we can show only like the whole battery information, but with like HANA battery or H4 battery, you can show each battery module the voltage and the temperature, some information, so you can know the system clearly, not only the inverter, but also the battery. The next one is also relate to our monitor system. So our monitor system can also like do the module level, panel module level monitor. If you have Tigo optimizer on your roof and you have account, you can connect your account to our monitor system, so we can get the information of each panel and show on in our monitor system. So then you don't, if in this may be also like AC coupling application, you do not need to switch to app to see the whole system. You can just log in the LXP monitor system to see all the data you need. So like the panel data, the inverter data, the battery data. So this is a brief introduction for our inverter. Next, we will go to the working modes, which is our topic today. There is a list for the working modes. So you can see that we have, in our inverter, we have self-consumption mode, charge first mode, peak shaving, AC charge, and forced discharge. And then next, I will explain all the modes for you one by one. Let's go to the self-consumption first. So for self-consumption, it is a default mode from our company. When you get the inverter, if you do not change any settings, then it will be a self-consumption mode. So for in self-consumption mode, the load will use solar first, and then battery and the utility. There are three situations we can explain in some detail. Like the first one is there is enough solar power, and then the solar power will first take the load and then charge the battery, and at last, if it's allowed to feed into the grid, then it will feed into the grid to sell the power to the grid power company. Then if the power is not, if you do not allow to use or power is not enough, then the power will take load first, and the battery will also discharge to take the load. So in the self-consumption mode, it will try to not use the power from the utility unless the utility is not enough. So it goes from the solar, like first use the solar. If solar is not enough, it will use the battery to discharge to take the load. And then if the load is bigger and the solar battery is not enough to take them all, then the grid will take the load together. So three, like solar, battery, and the utility will take the load together. This is for taking load. So if the solar is larger than the load, the solar will charge the battery. It's a very typical application in the, it's like in all inverters, you can find the self-consumption mode. So in this mode, you will try not to use the utility, and you save the energy in your battery and use for your own. So maybe you charge in the noon and discharge in the night. This is the self-consumption mode. The next one is PV charge first. So in self-consumption, the solar power will like take load first, but in the charge first mode, so it means that the PV will charge the battery first. Here is an example. So when the solar is enough, it will charge battery because the solar power may be higher than the battery needed. Then it will take load, and the last it will go to the grid. But when the solar goes down and it's lower than the battery request, then all the solar power will go to the battery, and then in this case, the utility will take the load. So the take power up sequence is like first the solar and then utility. At last is the battery. So we can see in this situation, when the battery, for example, is full, then the solar power will take the load. And then if the solar power is not enough, the utility will take the load. It will not discharge from the battery. So in the charge first mode, it means that the solar will charge battery first. And if there is extra power, it will take load. If there is not, it will only charge the battery, and the utility will take the load. So during the charge first mode, the battery will not discharge. It will avoid discharging. So because in this mode, we think the battery capacity is very important for the customer, then we cannot discharge from the battery. The next one is peak shaving. Peak shaving is a little bit complicated than the self-consumption and charge first. Peak shaving is you can do some settings like you can set here. You can set peak shaving SOC. You can set the peak shaving power and also the time. So it's like during the peak shaving time you set is the battery SOC is lower than your start SOC, then it will enter the peak shaving mode. Here is an explanation like this. So for example, you have like this is a charge per process, and when the battery is very low, it's lower than the on-grid setting, right? Then you have utility. So the inverter will use the grid power to charge your battery, and when the SOC is higher than on-grid EOD, then it means the battery can discharge. Then it will be in a peak shaving mode. So in peak shaving mode, it may charge or discharge according to the relation between your load and your peak shaving setting. So maybe let's go here, make it more clear. So you have your, for example, if you have your peak shaving SOC at 80% and your on-grid SOC at 20%, it means that during this range, so it means from the 80% to the 20%, this range, it is in a peak shaving range. And in this range, for example, your peak shaving power is 15 kilowatt. And so it means that you can get the maximum 15 kilowatt from the grid. So when there is, for example, when there is 10 kilowatt, if it's in this SOC range, then if the peak shaving is 15 kilowatt and you have like 10 kilowatt load, then there is extra 5 kilowatt you can use from the grid. Then we will use this 5 kilowatt to charge the battery. And if in this time, for example, you have 20 kilowatt load, then the load is higher than your peak shaving power, then we will discharge 5 kilowatt from the battery to make sure you always use like 15 kilowatt from the grid maximum. So this is still when in the peak shaving range from 20 to 80%. In this range, it will be in a peak shaving mode. So when the SOC is higher than this range, the inverter means that there is enough power in your battery, then it will go to self-consumption mode. For example, in now the SOC is 90% higher than your 80%. And if you have 10 kilowatt, then battery will discharge 10 kilowatt to compensate all your load to avoid you use power from the grid. So in this design, we mean that it's like for when there is enough power in the battery, we will discharge to compensate all your load. But when the SOC goes low, for example, lower than 80%, but higher than on-grid cutoff, it means you still have some power in your battery and you want to compensate the extra power to avoid the higher higher power cost. Then we will only compensate the difference. For example, the 5 kilowatt, this one, if you have 20 kilowatt, then we will discharge 5 kilowatt. So same 20 kilowatt, then here, we compensate 5 kilowatt to avoid. If you have like 25 kilowatt load, then we will compensate 10 kilowatt to avoid you exceed this power. So I'm not sure if I'm clear. I have this example, so for your reference, hope you can clear. For example, there is another example. The battery now is with 10% SOC here. Then the load is 5 kilowatt. Yes.
Three separate emails, chip in was green material and in was road material, good for good cell metal mixer.
Sorry, I cannot hear clearly.
You bet the three emails, chip in was green material and in was road material, ideal for good metal mixer and seeing them results worked. Sit on a whole three or come of an NS fabrics like Glenmundo on creating it all when you clear them. It's a
I think they're not.
I
think mostly just forgot mute the microphone.
Oh, okay. Okay, so let's continue. For example, the SOC is like now, we can start from here, it's 10%, and the load is 10 kilowatt. So if you set peak shaving, then we can use 5 kilowatt to charge the battery. In this situation, because the SOC is lower than the on-grid cutoff, the inverter will keep charging and to this, because in this range, it's still you have like 5 kilowatt ability to charge. So we will charge here until your loads go to 20 kilowatt. Then it's higher than the 15 kilowatt. Then we have to, sorry, here is discharge. So we have to discharge 5 kilowatt to avoid your consumption is higher than this setting. So when discharge, the SOC goes down until 20%, because 20% is the cutoff SOC. So we will stop discharging here and keeping standby. Then when get this time, the load change to 5 kilowatt. 5 kilowatt is lower than the 15. We have the ability to use 10 kilowatt to charge the battery. Then we will go to charge the battery. Keep charging until here. Actually go to the, there is your setting is 80%. So our logic is like when it's higher than 85%, it enters self-consumption mode. In self-consumption mode, if you still have load 5 kilowatt load, we will discharge to avoid you use the grid power. Then it will discharge until 80%. In 18%, then you go to the you go to this range again. Then we go to the peak shaving mode, and then if the load is 5 kilowatt, then here actually it's like we will only discharge. We will charge. Actually, we will charge again, because in the peak shaving mode. In the peak shaving mode, the load is lower than the peak shaving mode power. Then we will charge the battery again. So after the example, we can go back. So we can go back to this picture. Then when the SOC is low, the battery can only be charged in this range. The SOC is low. Then when the charge to are higher than your setting EOD, on-grid EOD, then it will enter the peak shaving mode. In peak shaving mode, depends on the load and the peak shaving settings. So we may charge or discharge. Then when we charge to the higher SOC, then we will go to self-consumption mode. And in self-consumption mode, the inverter will discharge the power your load is used from the grid to avoid the usage from the grid, from the utility. So when discharge is similar, only the range is a little different if it's go to its discharge process. So the value is a little bit different, but the process is same.
The 12 upon 4 in the aggregate.
Sorry, let me try to see. Okay, this is a peak shaving mode. The next one is AC charge. AC charge is a little bit, is much easier than the peak shaving mode. So if you want to use the AC to charge the battery, you set the charge power and the charge time SOC, then it will use the AC to charge the battery according to the settings. First discharge is similar. Then you need to set the power, the SOC, and the first discharge time to discharge from the battery. Then let's go to the setting part. This is our new setting page for the working modes, which is easier for users to understand. Here, there are some different colors for different working modes. For example, below the first one, active mode, is like what is the setting result from the customer. You can see here are the modes I just explained, like peak shaving, AC charge, PV priority, and the first discharge self-consumption modes. So there are many modes, and the customer may do many settings. So the active mode is the final setting customer, because also for this working modes, you can set different time. And this one is the final combination of the customer settings. Then it's very easy for customer to find what is the working mode now for this unit. For example, here, this is green. The green here means the self-consumption mode. The yellow means the backup or AC charge. The purple means peak shaving. Orange, peak priority, PV priority, charge priority, and the blue for the first discharge. So customer, here are the settings from the customer, and this is the final one. Then we can see that from the 0 to 9 AM, it is in self-consumption mode. And from 9 to maybe 10, it is AC charge mode. And in the purple, from 10 to 3 PM is like peak shaving mode. So actually you can, according to the color and the words here, you can see for the different time, you may set different working modes. It's very clear for you to understand now what is the time and the working modes. And also there are some working modes. We arrange the sequence as like the peak for the higher position here is high priority. You can see here for the customer, he enabled the peak shaving from 10 to 3 PM. Also, he enabled AC charge mode from 9 to 1 PM, 9 AM to 1 PM. So there are, for this time, from the 10 AM to 1 PM, there are conflicts. So in this situation, the higher position, you can see the peak shaving, the purple one is upper, and then it means high priority. It means that if customer enable the peak shaving and AC charge same time, then the peak shaving will take effect, and the AC charge will be like it's like disabled actually in this time. So also you can see this one. This is also there are conflicts from the customer setting. He enabled peak shaving and the forced discharge same time. Then in this situation, the peak shaving will take effect and the forced discharge will not take effect in this during this period. So it's like you can see originally if customer set this forced discharge, it should be a blue one. The whole bar should be blue. But because of some conflicts with other settings, for this part, it conflicts with the peak shaving. And in this period, it conflicts with the peak charge priority. Then for this two period, it changed to gray color to give a customer a notice that the setting have some conflicts. And finally, the higher priority one will take effect. So, and also that only here, there are some working modes you can have same time. Like we can, if customer enable AC charge and the PV charge priority, then it's no problem. If the two are both active and can take effect, there will be like two colors here. The first one and the second one. So there will be two colors here. This is the new design from our team to show customer, make it easy to understand what is the working modes now, to see all the, because before the settings are in different places and the customer may be confused because there are too many settings and he doesn't know why the system doesn't discharge or charge. Then here it's more clear. He knows that what is the working mode now. And then there are some also settings for each mode. We combined here. Only when you click here, there will be some settings. So now I will share our monitor system settings here. This is an inverter running in our lab beside me. You can see in Grace iPhone's picture. Can you see the picture? You still see my monitor system? Wait a minute. Okay, so I'm not sure if you can see the inverter in Grace iPhone. I can maybe switch to my camera here. Actually, like I have an inverter beside me, and we connect the PV battery and the AC, so I can show you some settings for the working modes. So you still see my monitor system, right? Okay. We can. So now I set the inverter to standby. We can go to maintenance page, and there is working mode here. Let's read. So now I set it to normal to let it work. Now we can see here the when you click here, you can set different working modes. So you can see on here. When you get the inverter, we can from the beginning peak shaving, we disable it. So when you get inverter from your distributor or installer, then it will be like 24 hours self-consumption. If customer, then we can go to backup mode. Actually, backup mode is very similar to AC charge. When customer enable backup function, then it will use the AC charge to charge the battery, to always keep the battery as a higher percentage. Then we can, now let's enable the backup. So you can see once you enable backup, it's like 24 hours backup. You can also set the AC charge power, because in the backup mode, we will always use, if there is no solar, we will use AC to charge battery to keep battery in a certain percentage. So let's go to the we can, now it's in backup mode. Then let's go to the monitor system to see the system running information. Now we have, so in backup mode, the battery will not discharge until there is no utility. I think maybe because of the charge power is higher than the AC charge requirements. So it's the extra power will feed into the grid. And let's see if we turn off the, for example, now we turn off the PV. I can turn off PV now, turn off PV, and turn on some load. So you can see, now I turn off the PV and turn on some loads. So you can see that in backup mode, the AC will take the load and charge the battery. So let's go to the other working mode here. Now let's disable backup working mode. Then it goes back to self-consumption. We can go to peak shaving, and there are some settings are already done. Then we can enable peak shaving. Then you can see, for example, if we set 5 kilowatt. Okay, after you see after I enable the peak shaving from 0 AM to 12, then here this one go to the purple, and also the active mode part, this one go to the purple. And let's, for example, enable AC charge also. We can enable it. So you can see here, from 2 AM to 11 PM, the AC charge is enabled for. So for this part, is your setting. You enabled this time for AC charge. However, because there are conflicts between the peak shaving and the AC charge mode, then this goes to gray, and only finally, during this time it will be peak shaving. This time will be AC charge, and the left, when you haven't said anything, it will be like self-consumption. Then if in peak shaving mode, I disable peak shaving, then your AC charge mode will be active. So this orange color, for this time it is like AC charge. We can also test. Let's disable AC charge and do some test for peak shaving too. Okay, now it's in peak shaving time. It's 5 AM, and it's in peak shaving time. The SOC is 70% setting, and the peak shaving power is 5 kilowatts. So let's see what should the inverter do now. 5 kilowatt and 70%. So first, we can see that 80% is higher than 70%. Then it means that there is enough power in the battery. So then in this situation, the inverter should go to like self-consumption mode. The battery will discharge to take the load. Because it's just from the other mode, is the inverter is doing mode switch, and it need time to reconnect to the grid. Let me see the inverter status here. Actually now the inverter is entering self-consumption mode. We can update the data. So you can see because the SOC is higher, and then it will discharge to take the load. So if, for example, we set the SOC to 90%, then it will go to, because 80% is lower than 90%, it will go to peak shaving mode. And let's see. So we go to peak shaving, and we set percentage, for example, for 90%. So now the SOC is lower than our setting. It will go to peak shaving mode. In peak shaving mode, then the load is 3 kilowatts. So let's, for example, set 1 kilowatt here. So it means that you can get 1 kilowatt maximum from the grid. Then you need to compensate the extra one. Now my load is about 2 kilowatt. So it will discharge 1 kilowatt. It's like 1.7 kilowatt. So it need to discharge from the battery. Let's see. So you can see that now the battery is discharged, and to avoid use to, because it's like 1.5 kilowatt, and the peak shaving is 1 kilowatt. Then it means you can use maximum 1 kilowatt from the grid. So I think it will adjust until it use only 1 kilowatt from the grid, and the others are from the battery. Then if we set a little bit higher here, then it can, for example, now my load is 1.7 kilowatt. If I set the power to 5 kilowatt, it means you can get 5 maximum from the grid, and the load is 1.7. Then you can charge the extra. We can change here. So now it should go to charge mode. You can see that now it's because it's increased the charge power step by step. It's now get the power from the grid and to take the load and to charge the battery, because the load is lower than your peak shaving power. Then we can go another mode. So I think for the other modes are simple. We can disable peak shaving. For AC charge, we can see some other settings, and since it's easy, I just explain the settings, and if you want, I can do some tests later to show you. So this is AC charge. You can enable and disable it. You can set the AC charge power from the utility, and also stop AC charge. For example, you can charge the battery AC charge according to time. And also, if you want to keep your battery at a certain SOC, if it's lower, you need to use AC to charge the battery, then you can set AC charge according to the SOC or voltage. And also this is the setting time. So the setting time is only will take effect when you choose charge according to time. So if you change charge according to SOC or voltage, then it will show your start AC charge SOC. So it means here means that when your SOC is lower than 5%, the system will use the AC to charge the battery. And when you're higher than the stop SOC, then it will stop AC charge. So this is according to SOC or voltage. Then if you choose according to time, then you can set 3 periods to charge the battery. Also, this is peak charge priority. Peak charge priority can enable, actually, if I enable AC charge. Now this is AC charge, and I enable PV first. Oh, so there is something wrong here. Then in these two working modes, they can be exist at the same time. So the active mode will be AC charge with charge priority. Then for the charge first, you can set the charge first power. For example, here we set 12 kilowatt, but if your solar has like 15 kilowatt, then 12 kilowatt will goes to charge the battery, and the extra 3 kilowatt will use to take the load. And when the SOC is higher than the stop charge first SOC, then the solar will be used to take the load first. then it goes back to the self-consumption mode. And this is the export PV only or forced discharge. Then you can enable the forced discharge and choose the discharge power and also stop discharge SOC and the time. So actually, I think for the customer, for me, normally I used this to test if the installation is right or the inverter is good. Because sometimes if you don't have enough load, it's in self-consumption mode. It will only, for example, discharge 1 kilowatt or some 500 volts. Then if you want to discharge more to test your whole system, you can choose forced discharge to test. For example, I enable it.
Padrone da quale me lo ci vedo del culo.
For example, 5 kilowatt.
Prepara.
Then now the inverter will go to discharge mode, no matter what is the load is. So you can see now the battery is discharging 5 kilowatt as setting, no matter what is the load from now. And the last one is self-consumption. So normally, when you do not do any setting change any setting, then it is self-consumption mode. Also, another thing is there is export PV only is used for California market. So they can only sell the original PV power to the grid. Then you can enable export PV only. Then, for example, if you have 5 kilowatts from your solar panel and you have 1 kilowatt load, so the battery will discharge to take the load and the solar will sell to the grid. I can show an example. I turn on the solar now for the inverter.
Yes.
So you can see that now the solar is about 3.5 kilowatt and the system will sell all this solar power to the grid. And there is load, the battery will take this load. So this is the PV export to the grid. That's all for the working mode setting. It's actually we work all here. So you can know what is the inverter status, what is the setting, and then it's very convenient for customer to use for this with this. Then because I can show before, it's like we have the settings all around here. Like we have AC charge here, charge first here, and we have forced discharge, peak shaving here. So when customer do some settings, he doesn't know what is the active mode now and what will take effect if there are some conflicts. So for the new page with this picture, you can know your system status and the settings very clearly. So this is much better than before, I think. That's all for today's working modes. Let's see if you have any questions.
I had one question. I see that you're recording this presentation. Can we get a copy of this for our colleagues that missed the call?
Yes, actually we will upload this to our YouTube channel. And if you want, you can leave a message here. I can send you a link after we upload to the YouTube.
Thank you.
Let me stop now. I think we can stop.
Thank you, Grace.
Yes.
I said thank you.
Yeah, you're welcome.